In our previous video, we were analyzing a situation where we have 100 emails and we're given some percentages as to how many of them are spam, and then of those that are spam, how many have the word buy in it, and of those that are not spam, how many of them still have the word buy in it. So we constructed some probabilities and we wanted to calculate the percentage of all the emails that had buy in it. We wanted to know what's the likelihood that that email is actually spam. And we found out that was 92%. So in translation, we can say that if an email does have the word buy in it, we can be pretty close to 100% certain that it is spam. So now what we want to do is we're going to construct Bayes' theorem. And Bayes' theorem basically does just what the table does. Now, I encourage you to construct the table because that's going to be much more intuitive oftentimes, but it's important to also be familiar of where this comes from. So I'm going to go back to what we wanted to calculate. We wanted to calculate where the condition is buy, what's the likelihood that the email is spam. But the conditional probabilities that we were given, the condition was that the email is spam, what's the likelihood that it has the word buy in it? So in order to calculate this probability here, we took the probability of S and B divided by the probability of B. So let's go ahead and write that out in terms of the other probabilities that we constructed along the way. So this is the probability of S and B divided by the probability of B. Now, how did we get the probability of S and B? That was this value up here, 0.48. The way we obtained that is in blue here, we multiplied the probability of S times the probability of B given S. So let's go ahead and replace that in our formula with how we computed that probability. So I'll use blue here again, and we'll say that the probability of S and B is the probability of S times the probability of B given S divided by the probability of B. Now the probability of B wasn't given to us. That was this 0.52 right here. So the question is, how did we get that 0.52? Well, that's how we're going to have to rebuild this denominator. So we already know that most recently that 0.52 was calculated by taking the sum of the 0.48 and the 0.04. Well, the 0.48, that's the probability of B and S, plus the probability of B and not S. But these two values were not originally given to us. We had to calculate both of these, and we know how we calculated those. We calculated those by these two formulas based on the information that we were given. So let's go ahead and rewrite this one more time. So the probability of B and S is equal to the probability of S times the probability of B given S. So let's go ahead and replace that. Probability of S times the probability of B given S. Now these are all, if you notice, these are all things that were originally given to us in the problem. Now we have to add to that the probability of B and not S, and that we calculated by taking the probability of not S times the probability of B given not S. So probability of not S times the probability of B given not S. And so this ultimately, we have all these equal signs here. This is what allowed us to calculate the quantity we wanted. And if you'll notice that all of the blue and green quantities were things that we originally had, then this formula takes care of all the computations that we were able to do in the table. Now, we didn't really need this formula in order to do it. We could use a lot of intuition, but this formula here is what is often known as Bayes' theorem. And we could always replace S and B with, if we were given the probability of B given S, then we would just have to switch around all of the terms here in order to reflect that. So this Bayes theorem, again, is something that we can always compute using a table. We did it. We had no issue constructing the values in the table and then calculating what we needed based on the completed version of that table. But again, it's just important to be familiar with this formula, whether or not you choose to use it.